Hi, my name is Joe Tang, and for the past decade, I've been developing robotics programs for youth outreach. And in this 3-part video series, I'm going to share with you my most popular one, the Autonomous Robot Racing for Everyone. I just started here at Tech Rockstar Academy as an instructor and developer, and we're going to adopt this program. So over the next 3 videos, you can see how you can build your own robot car, and how I'm going to upgrade it to use a neural network. So let's dive right in. I've developed and engineered several different types of robots for outreach, like for example these mini sumos that can be programmed in Scratch and wrestled. I've done these RC rovers that have FPV cameras, and they were used to celebrate the moon landing. I've also tried other types of robot racing like line following, but to make these tracks they're a hassle and it creates a lot of waste when I have to throw away that tape. So I redeveloped the idea of robot racing through making robots that can avoid walls. But you can adjust the sensors so you can change the way the car reacts on the racetrack, and you can also change out parts. It was so popular that I got to show it off at Open Source. Now I want to share with you how you can make these robot racers at home, and also what it takes to put a neural network on these robot cars. So let's take a look at what inspired these builds. In 2018, I discovered a new racing series called RoboRace, where they're making autonomous robots out of full-size race cars. And they were programmed to race around the track. They even took the world land speed record, making a robot drive at 135 miles an hour. So I knew I had to develop this into a program for youth. So I went looking for inspiration to make my own handheld version of a RoboRace car. The first thing I found was this toy from Japan called a Churro Q. We used to have these here in the States, and they were called penny racers. We'd pull them back and put a penny in the rear of the car, and it would do different tricks depending on how much weight you put in the back of the car. But this one's different. It's actually a full robot, where you can put it on this block here and charge it, and then you can select one of 2 programs. I'm selecting the first program, which allows it to avoid walls. Once you're done charging it, you can put it on the track, and it'll drive around. Now this robot has 2 infrared sensors, so it can detect objects in front of it and avoid them. This one even has an advanced backup protocol, so when it gets stuck, it backs up and turns around. Now the reason why I didn't use this in my STEM programming was 1, they were very expensive, and 2, hard to get. And also there wasn't a way to really tune these or add new code. It was kind of stuck with what I had. So next I found these. These are mini 4WD cars, where it has a single motor, and you can adjust their different rollers and weight to make them react differently on the track. Now, I almost went with this, but the track is really hard to come by, and it's really expensive. So what I ended up doing was building my own RoboRace car, since Mini 4WD had a 1/32nd scale version of it, and I mimicked what the Churro Q I's car was doing. And that was its title, is Churro Q I's. And so I added my own infrared sensors in the front that could be adjusted so I could change the way it drove around the racetrack. And this is what led ultimately to the robocars. It was really complex and fiddly to get all those electronics to fit inside that mini 4WD car. And I wanted a platform that was approachable for any skill level. So I developed this one, where it's just a plate where you can bolt on any readily available electronic, and you can adjust it. Now, these robots aren't programmed with code. Instead, they're adjusted by changing the angle of the sensor, changing the weight distribution, and swapping out the different brake pads, which are skids on the front of the car, which you'll see later in this video. You can see here when I pick it up, I can even adjust the sensitivity of the sensor by using a screwdriver and this thing called a pot. So you turn it up and turn it down. You can find the file to print your own robot race car in the description below. It'll lead you right to Tinkercad, and this is a modified version of my original one. I actually ended up making those clips you see, so that way you didn't have to use rubber bands to hold on the motor, because they dry out really fast here in California. So once you have that, go ahead and export it, and we'll move into the slicer. Now you can use any slicer that's available to you. I'm using the bamboo slicer since I have a bamboo A1 machine. Now here are my settings. I use 15% infill because I want some strength, but I want to keep it as light as possible to get the most speed out of my car. I also have to turn on supports. I suggest using tree supports because they're really easy to pull off. And because I print out a lot of these, because we hold in-person classes here at Tech Rockstar Academy, I put a brim on mine, so you don't have to do that. I do that just for safety, so it doesn't get knocked off the plate, or if there's a change in temperature, it'll stay stuck to the plate. So once you have that all done, you can go ahead and print it. Once you get off the build plate, go ahead and remove the supports and brims. The way I have them set up with my settings, it's really easy to peel off, so you can see here the brim just come right on off. And I just want to make sure that everything's clear, especially on these clips, because they're going to wrap around the motors pretty tightly, and any extra material is going to make it hard to get on. And then same with the wheels too. If you want it to roll smooth, make sure you get rid of all the brim. You don't want any bumps or protrusions, so it'll make the car uneven. And then finally with the brake pads, they're pretty easy, especially if you use tree supports. They come off nice and easy. You don't even need to use a plastic nipper or any kind of tool. Once you remove all the support material from your robot chassis, what you're going to want to do is find the front of it, and that's where those 3 horizontal lines are. Then we're going to use the adhesive on the mini breadboard to stick it to the center of the robot at the front. And we want to do this because it will help hold in the brake pads, and it'll also keep the robot driving in a straight line. Now I'm using a breadboard so we can distribute the power from the 9-volt battery to the sensor and the motor drivers. Once we have that done, we're going to grab the motor driver, and you'll see that big chunky block in the back there. That's a heatsink, and we want that towards the back of the robot. And we want all the blue inputs to the front. And what we're going to do is use an M3 screw, just 2 of them, one at the back corner and one at the front corner, to stick it to the center of the chassis. And you want to push it as close as you can to that breadboard. Once you put the breadboard on in the motor driver, here's what it should look like. As you can see, I used 2 screws, one at the front corner and one at the back, and that just helps reduce weight. And if you see underneath there, you can see some adhesive, and that's where we'll slide in the clips for the brake pads. Next, we'll take the battery box that has a switch, as you can see in the back towards the wires, and we're going to take some hot glue, and we're going to hot glue that to the chassis. Now just be careful when you're using hot glue. It is very hot, and it's easy to burn your fingers. And you can see there's a switch, and that's going to go to the very back of the robot. Now this is the orientation that the battery box should be in. You can see the switch and wires are all the way at the back. Just make sure you hot glue it to the chassis. Next, we're going to take some breadboard wires, one that has an input and a pin at the front. So the input's where you'd slide a pin in, and the pin is the shiny pokey part. And what we'll do is take a red and a black one, or an orange and a brown one, whatever one you have on hand, because this is for power distribution. And what we're going to do is we're going to keep the ends that have the output, which are the silver pins there. And we're going to remove the input side. And we're just going to put those off to the side. You can save them for a different project. And then we're going to strip the ends of the wires. So that includes the 2 pin wires and also the wires coming from the battery pack. What you want to do when you work with the battery pack is you want to definitely snip off what has already been pre-soldered. And that way it just makes it easier for you to twist the wires. So you can see here, that's what I'm doing. I'm just going to go over and snip the wires like that. And once they're clear, just wipe them away. And then go ahead and strip them. I use my fingers on these ones because it's easy. Or you can use a tool that I have here. Once you've trimmed the wires, you should twist the ends like this, and they should be stripped like that. You'll see at the front of the motor driver 3 inputs that you can unscrew, put wires in and screw down to connect them to the power. Now the orientation is red from the battery to 12 volts, the black and the black pin to ground, and the red pin to 5 volts. So next you'll attach the sensors to the chassis with screws, and then each of those sensors have a G&D and bin pin. For G&D you're going to want to slide on a brown and black wire with an output pin, and then for the VIN or VCC you're going to want to use a red wire and orange wire with a pin. Now for the outs, I'm using a breadboard wire that's extra long, and I'm using yellow and green, but you can use any color, but you'll see they both have inputs on it. And we'll lace that through the side slits that I put on the chassis. Before we do the sensor out pins, we have to distribute the power, and I did that by taking the same column on the breadboard and putting all of the red and orange wires next to each other and all the brown and black ones next to each other. And what that does is it distributes the power along those columns, because there's metal underneath there, and you connect them all together. So those 3 red wires connect the batteries and the sensors and the motor driver together, and then put them all to ground. And then finally we go ahead and lace through the sides the sensor pins and put them into N1 and N4 on the motor driver. The next step is to connect power to the motors and attach them to the motor driver. And to do that, I'm going to take these spare wires I have, and I'm going to cut both sides off here. And I only need about half the length since this is a really long wire. But I'm also going to get rid of those output pins, and you'll need 4 of any color. I believe I'm going to pick here yellow and green and blue and purple. So what I do here is I strip both ends off like so, and I'm going to twist those ends. And my camera here has a hard time focusing, but we'll twist the ends of this green wire And we'll also do the same for the yellow wire here. We'll strip that, and then we will twist it. And then what I'm going to do once they're all twisted nice and tight is I'm going to take the motor and I'm going to find the pad. And those motor pads are made out of copper. And you can see there's a little hole in them. I'm going to slide them up from the bottom here. The wire end that I twisted and stripped. And you might have to bend them a little. And then I'm going to bend that wire down, making a loop. Now you want to make sure it's very tight and then you can pull on it a little bit, or the wire will fall out like you see right there. So we'll just readjust. We'll slide it in, we'll push it down. And then right along the bell there, that black part of the motor, I'm gonna put a little dot hot glue to hold the wire in place. And this way we don't have to solder the wires to the motor. With the two motors completed now, I'm gonna pick up the chassis and find the motor inputs, which are those two blue inputs on each side of the motor driver. And all I have to do is unscrew them and you can slide the wire in and screw them down to make a connection. Now that the motor inputs are loosened, we're going to take this motor clip, and it has a little notch at the top, so that way you can orient it correctly. That notch should be at the top and towards the outside of the robot, so we'll slide that on. And once that's slid on, we'll take the motor, and you'll notice that the wires point to the inside of the robot, so make sure that's on the right side, so it's pointing to the inside. And this one can be a little bit fiddly, so just take your time with it. I had to readjust the wires quite a bit here just to get them to slide in. The nice thing about these wires, they are pretty flexible, but they do like to keep their shape once you bend them right. And just take some patience, and once you slide it in, you'll see that the clip expands, and you can lift it up and move it around. It's very flexible. And then you'll just slide the motor in, and there you go. And now it should be free moving too, so you can adjust the weight of the robot. And then we'll do the same for the other side. With the wheels being PLA, it makes them very slippery, so I'll have to add some tread. And I do that by using hot glue. I put down a little dot and I wipe it until it's nice and shiny and flat. And I continue this for both wheels until I have grip around the edge of both of them. The final step is to add the battery, wheels, and brake pad. What you want to do is line up the terminals on the battery with the terminals of the battery box, and you're going to want to slide that in gently. If you're having difficulties, you can use a little flathead screwdriver to gently nudge them on. Once that's done, we'll want to grab the wheels, and they do have a specific orientation. The motor has an oval-shaped shaft, and you want to align that oval shape with the oval shape cut out of the wheel. And they should press fit on. They are a little tight, but I did that so that they wouldn't roll off during a race. And once those are on, we'll make sure that the robot's driving forward. Sometimes the circuit gets backwards when you're wiring it. And you can see there on the right motor that it's driving backwards. So all I have to do is locate the wire that's attached to the sensor that controls it. So for this one, I believe it's the yellow one. As you can see, the green turns off the wrong motor. So we'll take the yellow one and we'll move it from in 1 to in 2, and that will reverse the motor's polarity, making it drive forward. So you'll see there's 1 and then move it to 2. And now the wheel's driving forward. Now that the robot's driving forward, I'm going to select a brake pad. Now each brake pad has a different level of friction and ride height. So you want to make sure that the robot's wires aren't touching the ground. And then you can select one of the 3 slots. I'm going to select the slot that's closest to the wheels, and that'll help it turn tighter. If you put it further away, it'll make it drive better in a straight line. As you can see here, you can slide into different slots, and the adhesive on the back of the breadboard helps keep it in place. Once you get the robot moving, it's time to test it out on the racetrack. And the racetrack can be made of many different materials. Here, I've ordered these RC car track walls, but you can use even cardboard from the box that you order all the parts in. Now, if you notice one of your sensors has both lights on and the motor isn't moving, that means it's detecting something. And you'll see on each sensor there's a potentiometer that you can use a screwdriver to turn up and turn down. What I like to do is turn it all the way up until you see the second light and then turn it down until it turns off. And that resets it to its max distance. Now that the car is moving, let's give it a try on the racetrack. I kept it standard just how we built it. And I have a track timer here, so let's see how fast it goes around the racetrack. Alright, around the first corner, through the chicane, and back around the last corner and across the line for a time of 6.2 seconds. Alright, now let's tune this car to go faster. Let's take a look at the racetrack first. There's a sweeping corner, a chicane, and another sweeping corner into a long straight. So I think the first thing to do is find a brake pad with less friction. So I'm going to get rid of this one since it has a lot. And I'm finding that it's slightly taller to keep those wires off the ground. And I think that was making the car grip up a little bit. I'm also going to move it up 1 slot. The further forward you push it, the better it goes in a straight line, so hopefully we can get through that straightaway a lot faster. Next, I'm going to adjust the sensors on the right and left. There's a lot of left corners, so that means the right sensor I'm going to push out further to see the left turn faster, and the other one in, so that way we don't wobble a lot between the walls. So let's see how we do. And off we go here. I'm going to adjust the starting line, and it looks like my start wasn't quite right. That's one thing you can also adjust, is where you start. That'll define how the car handles around the racetrack. Let me see if I can detect that corner a little faster so we can take it tighter. So I'm going to angle it here, and away we go. There we go, we're on the first corner, and then we're gonna hit the chicane. It looks like my sensor adjustments helped there. Went around last corner through the straightaway, and we have a 6.02. We knocked off 0.18 seconds. That's pretty fast. If you decide to build one of these cars, we'd love to hear from you. Go ahead and leave a comment below with any questions, or if you have tips to make these cars go even faster. We look forward to hearing from you. Now in the next episode, we're going to add an Arduino Nano to see if we can make these cars take the corners faster. And we'll also show off a prototype of the neural network card that has the same electronics and same inputs. And we'll talk a little bit about what it takes to actually train one of these cars to go around the racetrack. So if you want to see the next episode, like and subscribe, and we'll see you next time.